What is a base?
A compound that accepts hydrogen ions, Brønsted-Lowry acid. Has a pair of available electrons, Lewis, or releases hydroxide ions in solution, Arrhenius.
How does ethanol work as a fuel?
Ethanol works as a fuel in much the same way as gasoline. It is burned in a combustion reaction to release energy. In automobiles, ethanol is usually mixed with gasoline.
What is a geometric isomer?
A molecule with the same molecular formula but different arrangement of those atoms in space.
How can I make invisible ink?
Chemistry principles encountered in this experiment. Evaporation combustion reactions acid/base reactions materials you'll need, cotton swab or paintbrush heat source. Can be a light bulb, measuring cup paper baking soda water grape juice, optional, the procedure. To prepare the ink, just mix equal volumes of water and baking soda and stir well. Take a cotton swab, paintbrush, toothpick, or something similar, and write a message on a piece of white paper using the water and baking soda mixture you have prepared. Allow the ink time to dry. The water will soak into the paper and eventually evaporate. But the baking soda will not evaporate and it will be left behind. To read your invisible message there are a couple of options. One is that you can hold the paper to a heat source, such as a light bulb or gentle flame. Don't burn the paper. This should cause the baking soda on the paper to turn brown, revealing your message. The baking soda burns faster than the paper, which is why it turns brown before the paper does. Another option is to spread purple grape juice over the paper. You can use a paintbrush to do this. The message should appear in a different color/shade compared to the rest of the paper. This works because an acid in the grape juice reacts with the sodium bicarbonate that you used to write your message.
Is a calorie in food the same as the unit of energy used by scientists?
The calories listed on food labels are actually kilocalories when converted to standard units for energy. So if the package for your snack says it contains 100 calories, that's really 100,000 calories in the units of energy used by scientists.
Why did Dan Shechtman, Israel, win the Nobel Prize for Chemistry?
for the discovery of quasi-crystals. In discovering quasi-crystals, Schechtman initially made some people think he was foolish and just plain wrong. Using a microscope, he found patterns of molecules that appeared to be packed in repeating patterns. But these were patterns that should not be allowed to repeat in a periodic way by simple arguments of geometry. This controversial discovery, and Schechtman's defense of what he observed, led to his being asked to leave his research group at the time of he made the initial discovery. After fighting a long battle, he eventually reached the point where his discovery was recognized. To date, quasi-crystals have not found too many important applications. But they have made scientists rethink the fundamental properties of solid matter, which is certainly a pretty big deal.
What is a metal?
An element, compound, or alloy that is a good conductor of heat and electricity. Also usually reflective, ductile, and malleable.
What is fracking?
Hydraulic fracturing, or fracking, is a technique used to break up rock deep underground in order to release the natural gas trapped inside it. The fluid injected into the rock is generally water-based. But the specific mixtures of chemicals dissolved in that water are generally a closely guarded secret. Using fluids to crack rocks is an old technique dating back over 100 years. But modern techniques trace back to experiments in the 1940s by Floyd Ferris and J.B. Clark, who worked for Staniland Oil and Gas.
What makes a reaction happen spontaneously?
A spontaneous chemical reaction is one for which the associated change in Gibbs free energy is negative. The fact that a reaction is spontaneous actually doesn't tell us anything about how quickly the reaction takes place, though. A spontaneous reaction may happen very quickly or take thousands of years.
What is astrobiology?
Astrobiology is a branch of science concerned with looking for signs of life. Basically, anywhere other than on planet Earth. This isn't really the search for space aliens hanging out in close vicinity to our own planet. But rather astrobiology is focused on looking for any evidence for the current or prior existence of even the smallest, microbial, life forms elsewhere in space.
What is a pK?
The logarithm of an acid dissociation constant.
What makes a rubber band stretchy?
Rubber bands are made up of long, tangled up, chain-like molecules called polymers. These long chains prefer to be tangled up because it maximizes their entropy, or just the number of ways they can arrange themselves. See Physical and Theoretical Chemistry for more on entropy, or Polymer Chemistry for more on polymers. When we stretch a rubber band, it straightens out these long chain molecules into a state with less entropy. So basically there are fewer stretched out conformations possible than there are tangled up ones. When we release the rubber band, it contracts to a more disordered state. Primarily just because there are more possible conformations associated with the contracted length.
What is the hapticity of an organometallic ligand?
The hapticity of an organometallic ligand is a pretty simple concept. It just tells how many atoms from a given ligand are coordinated to the metal center. This is typically denoted in chemistry literature with the Greek letter eta.
What is a band gap?
The energy range separating the top of the valence band and the bottom of the conduction band in a semiconductor.
What is Dalton's law?
A law regarding partial pressures of gases that states the total pressure of a mixture of gases is equal to the sum of the partial pressures of each individual component.
Can radio telescopes detect any kind of molecule?
Radio astronomy can only detect molecules with dipole moments. And the stronger the dipole, the easier it is to detect. As a result, carbon monoxide, Ca, is very easy to detect in space because of both its strong dipole moment and its relative abundance.
What is interference?
Superposition of two or more waves, resulting in either higher constructive, or lower destructive amplitude.
What is a formal charge?
The amount of charge, typically in integer units of electron charge, assigned to a specific atom in a molecule.
How are sugars stored in the body?
The body converts excess sugars into a branched polymer called glycogen for storage. In plants, sugars are instead stored as a polymer called starch.
What is an isotope?
Isotopes are atoms with the same number of protons and electrons, but with different numbers of neutrons. The most important thing to keep in mind is that the number of protons determines the element we're dealing with. In most areas of chemistry, this is enough to determine the reactivity of the atom. Though in nuclear chemistry the number of neutrons is also quite important in determining the nuclear processes an isotope can undergo. Please refer back to the Atoms and Molecules chapter for additional information on isotopes.
What is the DNA?
An acronym for deoxyribonucleic acid, which is the biomolecule that stores genetic information in organisms.
What is osmosis?
The diffusive process of solutes moving from areas of higher concentration to lower concentration.
What is a noble gas core?
Used to abbreviate an atom's electron configuration, e.g., the electron configuration of nitrogen is 1s22s22p3, which can be abbreviated He2s22p3.
What is endothermic?
A process or reaction that absorbs heat.
What is the second law of thermodynamics?
There are several different statements of the second law of thermodynamics, but they are all centered on the idea of identifying what things can happen spontaneously in nature. One formulation of the second law states that, for a closed system, the entropy of the system can only increase or remain the same. In plain language, this says that nature favors having more accessible configurations or arrangements. It's why, for example, a drop of ink in water tends to spread out to fill its accessible volume but won't spontaneously reform a drop of ink. Another statement of the second law says that heat cannot spontaneously flow from a colder body to a warmer body. Work would have to be done for this to happen, which would imply the process was not spontaneous.
What is an atomic orbital?
an equation that describes the probability of finding an electron around a nucleus.
What is the 18-electron rule?
Earlier we talked about the octet rule, which says that elements like carbon and oxygen are most stable when they have 8 valence electrons. For transition metals, as we've mentioned, the d orbitals start to become important. So 8 electrons just aren't enough anymore. Since there are 5 d orbitals, we need an additional 10 electrons to fill the valence shell. And 8 plus 10 equals 18, hence the 18-electron rule for transition metals.
What is atomic emission spectroscopy, ES?
AES measures the wavelengths of light that are emitted, or absorbed, when a sample is burned. The wavelengths of the spectral lines are unique to each element because the energy of the photon released from the atom depends on the electronic structure of the particular atom.
How many stars exist in total?
This is a difficult question to answer, but we can provide a very rough estimate. In our galaxy alone, there are roughly 1011 to 1012 stars. Then consider that there are roughly 1011 to 1012 galaxies in total, and if we assume the other galaxies are similar to ours, this would put the total number of stars in existence somewhere between 1022 to 1024 stars. Clearly there are too many to count.
How are herbal medicines prepared?
There are many ways of preparing herbal medicines. Tinctures and elixirs are extract ions of herbs using some solvent, usually ethanol. If a plant is extracted with acetic acid, the solution is known as a vinegar, even though the solvent is also vinegar. A tisane uses hot water to extract herbs like tea.
What is extraction?
Removal of one or more substances from a mixture. Typically based on differing solubility of a substance in a solvent.
What are some common structures/geometries for molecules?
The study of chemistry has benefited greatly from knowledge of properties relating to the geometries and, especially, the symmetries of molecules. To get a sense of what shapes molecules adopt, it's worth taking a look at a few of the geometries that come up often in the study of chemistry. One commonly encountered geometry is that of a tetrahedron. Methane has the molecular formula CH4 and exists in a tetrahedral geometry, with angles of approximately 109 degrees between each pair of CH bonds. Linear geometries are also relatively common. Carbon dioxide has the molecular formula CO2 and exists in a linear geometry with a 180-degree angle between the co-bonds. One last geometry we'll look at here is a planar geometry. The molecule BH3 provides one example of a planar geometry. And in this case the BH bonds are separated by angles of 120 degrees. There are also planar molecules with 4 bonds in a plane. And in those cases the bonds are separated by angles of 90 degrees.
Will you contract poison ivy if you come into contact with a person who has it?
Poison ivy is caused via an oil called urushiol, found on the leaves of poison ivy plants. The only way to contract poison ivy is to come into contact with this oil. Thus, if a person who has poison ivy still has some of the oil from the plant present on their skin, they could spread that oil to another person. In most cases, though, by the time a person has a rash, the oil will have been washed away. To be clear, the blisters on a person's skin who is suffering from a poison ivy rash do not themselves have the potential to spread poison ivy to other people.
Does hot water really freeze faster than cold water?
Sometimes. This observation is known as the Mpemba effect, named after the Tanzanian student who in 1963 resurrected the idea from Aristotle, Francis Bacon, and René Descartes. Whether or not this effect can be seen seems to depend on so many variables, the size and shape of the container, the initial temperatures of the two liquids, the method of cooling, on how you define freezing, when the first ice crystal forms, when there's a solid layer on the top, or when all of the water has frozen solid, that it's really still unclear if this effect is real or not.
What is fluorescence?
Fluorescence is a process by which molecules that have absorbed light can re-emit light to release some of the energy they absorbed. For fluorescence to take place, a molecule must first absorb a photon of light, which causes an electron to be excited to a higher energy level. At the same time, this process will typically also cause some vibrational excitations to take place. Some of the energy associated with this absorption will be given off through relaxation of the excited vibrational energy levels. For fluorescence to occur, the electronic excitation relaxes by emitting a photon of light. Some of the energy was dissipated as the vibrational energy levels relaxed. So the photon that is emitted has less energy than the photon that was initially absorbed. Remember that less energy means a lower frequency. So the photons that are emitted have a lower frequency than those that were absorbed.
What was the first chemistry textbook published?
Although numerous chemistry texts exist before it, Alchemia, published by Andreas Libavius in 1597, is considered to be the first organized chemistry textbook. Libavius, born in Halle, Germany, in 1555, was a chemist and a medical doctor, and also served as a schoolmaster at the end of his life. In addition to his noteworthy textbook, Libavius is significant in the history of chemistry for further advancing the discipline away from the realm of magic, the occult, and alchemy toward a teachable, logical, and scientific discipline.
What is a Lewis acid?
A molecule that can accept a pair of electrons.
Can multiple liquid phases exist for a mixture?
Yes. One familiar example is a mixture of oil and water. The immiscible oil and water phases are two different phases of liquid matter.
What is the charge of a molecule?
The overall charge of a molecule is determined by the number of protons and electrons in the whole molecule. If there are more protons than electrons, the molecule will possess an overall positive charge. If there are more electrons than protons, the molecule will similarly possess an overall negative charge. A molecule with the same number of electrons and protons is neutral and has no net charge.
How is radiation exposure quantified?
The scientific unit for radiation exposure is the sievert, SV. Though several other types of units do exist. The maximum radiation exposure that is allowable for occupational exposure in the U.S. is 50 millisieverts, MSV. For comparison, the average natural background level of exposure is roughly 3 MSV.
What is absolute zero?
Lowest theoretical temperature, 0.00 K, minus 273.15 degrees Celsius, minus 459.67 degrees Fahrenheit.
Mitchell, United Kingdom, win the Nobel Prize for Chemistry?
For his contribution to the understanding of biological energy. Transfer through the formulation of the chemiosmotic theory. Mitchell received the prize for developing a theory of how electron transfer was coupled to ATP synthesis during oxidative phosphorylation and photophosphorylation. He proposed that a gradient of proton concentration, and thus also charge, was built up across the mitochondrial membrane, and that the reverse flow of protons down the concentration gradient provided the driving force for ATP synthesis. This is what is known as the chemiosmotic theory. Why did Herbert C.
What is an aqueous solution?
An aqueous solution is any solution in which water is the solvent. This term is used pretty frequently in chemistry, so it's good to be familiar with it.
What is entropy?
A measure of the disorder, or dispersion of energy, in a system. The second law of thermodynamics states that a spontaneous change cannot decrease the entropy of an isolated system.
What were some early models for the atom?
Experiments suggested that atoms were actually made up of smaller particles, which motivated the development of new models involving protons, neutrons, and electrons. One was Thomson's plum pudding model, which described the atom as a positively charged pudding filled with negatively charged electrons. Rutherford later proposed the idea of a positively charged nucleus, but couldn't explain why electrons didn't just fall into it. A Danish physicist named Niels Bohr proposed the idea that electrons travel around a nucleus in specific orbits and advanced the atomic theory to a point very close to where it is today.
What kinds of safety precautions are typically taken when working in a chemistry laboratory?
Chemists working with chemicals in a laboratory typically wear safety goggles to protect their eyes, a lab coat to protect their skin and clothes, and a pair of gloves to protect their hands. Of course, there are many situations when additional specialized protective gear is necessary.
Why is ultraviolet light from the sun potentially dangerous?
Most of us like being out in the sun, but we've also all heard to be careful not to get sunburned, since too much sun can cause serious problems like skin cancer, along with less serious problems like wrinkles and dry skin. The sun can damage your skin because the ultraviolet rays from the sun are relatively high energy photons that can damage the elastin fibers in your skin. These can then lose their ability to go back to their original position after they are stretched, and also lose their ability to heal as quickly when wounded or bruised. As we discussed briefly in biochemistry, the cause of cancers generally involve damage to the genetic material, DNA, of your cells, which interferes with their ability to replicate, or stop replicating, normally. With regard to cancers arising from too much exposure to ultraviolet radiation, DNA can be damaged in two ways. The first, probably more obvious, route is that the ultraviolet radiation could be absorbed by the DNA directly, causing changes in its chemical structure. The second possibility is that ultraviolet radiation can be absorbed by other molecules first, forming reactive, damaging radical species, like hydroxyl radicals or singlet oxygen, which then diffuse through cells and can damage DNA.
How does a pressure cooker speed up cooking?
If the lower atmospheric pressure in Denver increased cooking times by lowering the boiling point of water. What if we could increase the boiling point of water? That's exactly what a pressure cooker does. Pressure cookers are sealed such that once you start to heat water, the pressure inside the vessel increases. This increase in pressure drives up the boiling point of water because every water molecule that tries to make the transition from water to liquid has a greater force pushing against it. By increasing the pressure inside the pot, pressure cookers can get the boiling point of water up to about 120 degrees Celsius, 250 degrees Fahrenheit. With water boiling at a higher temperature, your food cooks faster.
Who first proposed the idea of elements?
Plato is often given this accolade as he was the first to use this term for his description of the 5 basic shapes that he believed made up the entire universe: tetrahedrons, icosahedrons, dodecahedrons, octahedrons, and cubes. He went on to ascribe each shape to a basic element, borrowing from Empedocles. See next question. The tetrahedron was fire, icosahedron, water, dodecahedron, ether, octahedron, air, cube, earth. While this association of basic geometrical shapes to the nature of the universe obviously didn't work out for him, Plato's ideas did lead Euclid to invent geometry.
If cooking spray is just oil, then how can it have 0 calories and no fat?
Cooking spray lets you apply a thinner layer of oil than you could probably achieve by pouring normal liquid vegetable oil out of a bottle. The FDA states that any food substance with less than 5 calories and less than 0.5 g of fat per serving can be labeled calorie-free and fat-free, respectively. So manufacturers of cooking spray adjust the recommended serving size to contain less than those limits. As a result, your can of spray contains hundreds of servings. Go check your pantry if you don't believe it.
What is a glycosidic linkage?
A glycosidic linkage is the chemical bond that bonds a carbohydrate to another carbohydrate molecule or to another species. Glycosidic linkages are what hold together all of the individual glucose monomers that make up glycogen or starch. The figure below shows a glycosidic linkage. The enzymes that catalyze the breakage glycosidic linkages are called glycoside hydrolases. These are necessary to allow for glucose to be released from storage. The enzymes responsible for forming the linkages are called glycosyltransferases.
What is frequency?
Rate of an event per unit time.
Is there a reason all amino acids in biological systems share the same chirality?
While the answer to this question is uncertain, there have been some interesting developments in this area. It has been shown that life, as it exists today anyway, cannot arise from a racemic mixture of amino acids because the presence of chiral centers in many biomolecules is crucial for biological function. The self-replication of DNA relies on the presence of chiral centers and without a shared chirality, the error rate in DNA replication would cause severe problems for many longer-lived plants and animals. One hypothesis for the origin of chirality is that molecules from outer space reached Earth with a net chirality already present. Another is that the net chirality in amino acids was established on Earth in a very short period of time. It's a pretty interesting thing to think about, and this topic is a subject of ongoing research and debate.
How was the modern periodic table developed?
A French geologist named Alexandre Bigurier de Chancourtois is actually the first on record to list all of the elements in order of increasing atomic mass. His first version contained 62 elements and they were placed in columns that wrapped around a cylinder. However, there were a variety of issues with this first attempt that were later improved upon. Newlands made the next significant advance, publishing the elements in columns of those with similar properties, which brought the description close to the version chemists use today. The modern version of the periodic table was proposed by a Russian scientist named Dmitry Mendeleev in 1869. His table was the first to lay out the elements in order of increasing atomic mass in columns of elements with similar reactivity. Elements on the table appeared periodically, essentially in accordance with the law of octaves, hence the name the periodic table. Mendeleev's table had to include some blank spaces so that the elements were each in the proper column according to reactivity. As more elements were discovered, the blank spaces in the table were eventually filled in, validating Mendeleev's table.
What is a hydrogen bond?
Interaction between a hydrogen atom bonded to a highly electronegative atom and a Lewis basic atom.
What is the hapticity of an organometallic ligand?
The hapticity of an organometallic ligand is a pretty simple concept. It just tells how many atoms from a given ligand are coordinated to the metal center. This is typically denoted in chemistry literature with the Greek letter eta.
If baking soda and baking powder are different, how can I substitute one for another?
Since baking powder is diluted baking soda with acid. If your recipe calls for powder but you only have soda, you'll need to use less, but add an acid. Generally the ratio is 3 parts baking powder equals 1 part baking soda with 2 parts cream of tartar, or another acid substitute.
What is the yield for a reaction?
The yield of a chemical reaction is the amount of product that is produced. An example might be 2 grams. It is often of greater interest to consider the percent yield, which describes the amount of product formed relative to the maximum amount of product one could have expected based on the quantities of reactants used. The percent yield provides a measure of how efficient a process is for producing the target product.
What is a reductant?
A reducing agent, or a species that gives electrons to another species.
What is the decay rate?
Rate at which a nucleus emits a particle.
What is the sticky stuff that you lick to seal an envelope?
The glue that you lick on the seal of an envelope is typically a substance called gum arabic, which is made of polysaccharides and glycoproteins. This gum can be found in the sap of acacia trees.
What is a peptide?
A polymer of amino acids.
What is weight?
The force applied by gravity on an object.
What is a Kelvin?
Standard temperature scale in which the triple point of water is defined at 273.16 Kelvin.
Why do some substances smell stronger than others?
There are a couple of reasons that a substance might smell stronger than another. The first is volatility, or vapor pressure, of the molecule you smell. Simply, if there is more of it, it smells stronger. Additionally, some molecules interact more strongly with the receptors in your nose than others, which results in a stronger smell sensation.
How are soft drinks carbonated?
Soft drinks are carbonated using pressurized CO2 gas and a siphon that introduces the pressurized gas into the water or soda. The CO2 gas is forced into the liquid at a concentration beyond that which could exist under atmospheric conditions, and then the container is sealed, preventing it from being released. That's why if you leave a glass of soda sitting out, it will go flat, the CO2 escapes into the air.
Can radio telescopes detect any kind of molecule?
Radio astronomy can only detect molecules with dipole moments. And the stronger the dipole, the easier it is to detect. As a result, carbon monoxide, CO, is very easy to detect in space because of both its strong dipole moment and its relative abundance.
How long ago was the light we see from stars emitted?
To figure out how long ago the light we see from stars was emitted, we have to know roughly how far away the star is and use the known speed of light, approximately 3 × 108 meters per second. The Sun is roughly 150 million kilometers from the Earth, from which we can calculate that sunlight reaching the Earth left the Sun roughly 8 minutes ago. the distance to the next nearest star is much farther, roughly 410 x 1011 kilometers from Earth. This translates into a time of over 4 years between when light leaves this star and when it reaches telescopes on Earth. Keep in mind that this is the next nearest star, so all others are even farther away. This also means that, if we see a star explode, it really happened many years ago.
What is an ultraviolet?
Electromagnetic radiation with wavelengths of 10 nanometers to 400 millimeters. Just shorter than the visible spectrum, but not as short as X-rays.
Why did Max Ferdinand Peretz and Jean Caudery Kendrew, both United Kingdom, win the Nobel Prize for Chemistry?
For their studies of the structures of globular proteins. Peretz and Kendrew sought to elucidate the structures of large proteins using X-ray diffraction techniques, with a particular focus on hemoglobin and myoglobin. They took a variety of innovative approaches, including recording a huge number of X-ray diffractions, about 250,000, incorporating heavier gold or mercury atoms at well-defined locations into the molecule, and using a computer, one that was advanced for the time, to process the large amounts of data they collected. This was quite a challenging task, as even myoglobin, the smaller molecule of the pair, contains roughly 2,600 atoms. Their work was the first to help understand the principles behind the structure of globular proteins.
What is the Raoult's law?
States that the vapor pressure of a solution depends on the amount, mole fraction, of a solute added to it.
Why do hard-boiled egg yolks turn green?
When egg whites cook, a small amount of hydrogen sulfide, H2S, is released from sulfur-containing amino acids like cysteine or methionine. If the H2S migrates to the yolk, it combines with iron atoms to produce ferrous sulfide, FeS, which is a dark-colored material that looks green mixed with the bright yellow yolk. Ferric sulfide, Fe2S3, is also sometimes claimed to be formed in this process, likely because it is itself a yellow-green substance. There is, however, less data to back this up, aside from the convenient color match.
Lipscomb, United States, win the Nobel Prize for Chemistry?
for his studies on the structure of borans illuminating problems of chemical bonding. Boron hydride, borane, complexes participate in many interesting examples of chemical bonding. And this is due to the fact that boron possesses one less electron than carbon to donate to chemical bonds, but still often forms four coordinate complexes. Lipscomb won the prize for his pioneering explorations of the chemistry and bonding in borane complexes using X-ray diffraction and quantum chemical calculations. He reached a level of understanding of borane complexes at which he could predict the properties and reactivity of borane complexes reasonably well. And his work led to deeper insight into the nature of the chemical bond.
Why did Walter Kohn, United States, win the Nobel Prize for Chemistry?
For his development of the density functional theory, and John A. Popel, United Kingdom, for his development of computational methods in quantum chemistry. Kohn and Popel represent two of the founding fathers of modern computational chemistry methods. Density functional theory is a method that relies on the function describing the spatial electron density in a molecule to calculate molecular properties. And Kohn was awarded the prize for his substantial contributions to the development of this now widely used approach. Popel also made major strides toward making computational methods reliable and accessible to a large number of chemists. In addition to his more technical achievements, Popel is responsible for developing the Gaussian computational chemistry software that is probably the most widely used computational chemistry tool available today.
Why did Svante August Arrhenius, Sweden, win the Nobel Prize for Chemistry?
For his electrolytic theory of dissociation, Arrhenius began studying as a graduate student at the University of Uppsala how much electricity solutions of various molecules could conduct. He correctly proposed that solution of salts were conductive because the salts formed charged particles, later named ions, even in the absence of an electric current. His advisors weren't very impressed, and he earned a third-class degree in 1884. Arrhenius continued to develop the work, and was soon awarded the Nobel Prize for his insights.
What kind of fuel is used to power a spacecraft?
The Space Shuttle Endeavour, which made its final space voyage in September of 2012, used primarily hydrogen, oxygen, hydrazine, N2H4, monomethylhydrazine, CN2H6, and nitrogen tetroxide, N2O4, as fuels. As it took off for a space voyage, the spacecraft would carry 958 gallons of these fuels with a total weight of roughly 1.6 million pounds.
What is green chemistry?
Green chemistry is the practice of designing chemical products with the goal of minimizing the amount of hazardous waste that is generated in the process. This is frequently a complex issue since one needs to consider not just the synthesis of the chemical product but also the sources from which the reagents are obtained, the manufacture of the product, and the end of the product's life cycle. In a seminal book on the topic, Paul Anastas and John Warner defined green chemistry as the utilization of a set of principles that reduces or eliminates the use or generation of hazardous substances in the design, manufacture, and application of chemical products.
What is the Presidential Green Chemistry Challenge Award?
These awards were created in 1995 in an effort to promote and recognize innovation in green chemistry in the United States. 5 awards are given each year to individuals or companies for work in green chemistry in the following categories: academic, small business, greener synthetic pathways, green reaction conditions, and designing greener chemicals. Away from individual companies and placed it on the government agency. These laws received criticism for not incentivizing research and education regarding green chemistry in the industry. Due to widespread opposition to the initially proposed regulations, the implementation of this initiative had to be postponed at least once due to the need to rewrite the proposal.
Why does milk go sour?
Milk, even milk that has been pasteurized, contains a bacteria called lactobacillus. The first part of the word, lacto, refers to the sugar that these particular bacteria eat, lactose. When these bacteria process lactose, they secrete lactic acid. It's this acid that makes milk taste sour and leads to curdling. It actually doesn't have to be lactic acid that curdles milk, any acid will do. Try taking a small glass of milk and adding lemon juice or vinegar to it. The milk will start to curdle just the same.
What is temperature?
Temperature is a measure of the average kinetic energy of particles in a substance.
What determines the most favorable packing arrangement?
Thermodynamics. Okay, that's a cop-out answer. Attractive interactions, like van der Waals forces or hydrogen bonding, can play a large role in determining the stability of a crystal lattice. The most stable packing arrangement can also depend on the pressure and temperature at which the crystal forms.
Why is ultraviolet light from the sun potentially dangerous?
Most of us like being out in the sun, but we've also all heard to be careful not to get sunburned, since too much sun can cause serious problems like skin cancer, along with less serious problems like wrinkles and dry skin. The sun can damage your skin because the ultraviolet rays from the sun are relatively high energy photons that can damage the elastin fibers in your skin. These can then lose their ability to go back to their original position after they are stretched, and also lose their ability to heal as quickly when wounded or bruised. As we discussed briefly in biochemistry, the cause of cancers generally involve damage to the genetic material, DNA, of your cells, which interferes with their ability to replicate, or stop replicating, normally. With regard to cancers arising from too much exposure to ultraviolet radiation, DNA can be damaged in two ways. The first, probably more obvious, route is that the ultraviolet radiation could be absorbed by the DNA directly, causing changes in its chemical structure. The second possibility is that ultraviolet radiation can be absorbed by other molecules first, forming reactive, damaging radical species, like hydroxyl radicals or singlet oxygen, which then diffuse through cells and can damage DNA.
How can I make hot ice, sodium acetate?
Chemistry principles encountered in this experiment. Chemical reactions: solubility, crystallization and recrystallization, colligative properties. Materials you'll need: pan with cover, microwave or stovetop, vinegar, 1 liter, baking soda, 4 tablespoons, dish. The procedure: pour the vinegar into a pan, and very slowly, a little bit at a time, add the baking soda. As you may already know, this reaction will produce large amounts of bubbles, carbon dioxide gas, so you'll need to add this very slowly. This reaction will produce a solution of sodium acetate in water. Sodium acetate is produced according to the chemical equation: Na plus HCO3 plus CH3COOH CH3 Na plus H2O and CO2. Bring the solution to a boil. Allow the solution to continue to boil until a skin or film begins to form on the surface of the solution. This will require heating for a significant amount of time, perhaps up to an hour, until a large fraction of the water from the vinegar has evaporated. Our goal here is to form a very concentrated hot solution of sodium acetate. You'll recall from our discussion of colligative properties that the solubility of a solute is higher at higher temperatures. As we reduce the volume of the water, the sodium acetate will not evaporate, and we will be left with a concentrated solution at high temperature. When you notice a film start to form on the surface, Remove the pan from the heat, and cover it to prevent further evaporation. Place it on the countertop or in the refrigerator to cool. If you see any crystals begin to form, add a small amount of additional vinegar, or if you are out of vinegar, use water and stir the solution so that they dissolve. You now have a supercooled solution of sodium acetate that can crystallize out of solution readily if a crystallization nucleus is present. You can now slowly pour the first few drops of the cooled solution onto a dish, and it should begin to crystallize rapidly. If it doesn't, try dragging a fork or knife along the dish to make a tiny scratch. Or give the liquid a moment to evaporate a little so that the sodium acetate begins to crystallize before you begin to pour. As you continue to pour, the liquid should continue to crystallize as it contacts the crystals already formed on the dish. This is similar in spirit to how purification takes place during a recrystallization. See the modern chemical lab. If you feel the crystals, they will be warm to the touch. Since the crystallization is an exothermic process, it gives off heat. This is why it's called hot ice. But now you know it isn't really ice, it's sodium acetate, and you know how to make it.
What is the valence shell of electrons?
Electrons fill up orbitals in shells. The innermost shell consists of just one s-type orbital and can hold just 2 electrons. The next shell consists of one s-type and 3 type orbitals, and can hold 8 electrons. Higher shells consist of more and more orbitals and can thus hold more and more electrons. The valence shell of electrons is the highest occupied, or partially occupied, set of orbitals.
Why did Richard F. Heck, United States, Eiichi Negishi, Japan, and Akira Suzuki, Japan, win the Nobel Prize for Chemistry?
For palladium-catalyzed cross-couplings in organic synthesis. Heck, Negishi, and Suzuki shared this prize for their development of a class of reactions called palladium-catalyzed cross-couplings. These reactions are a powerful tool in organic synthesis, allowing chemists to form carbon-carbon bonds, which is generally not an easy task at all. The reaction is accomplished by having the carbon atoms first join to a common palladium center, from which point carbon-carbon bond formation can proceed.
What is typically analyzed when a doctor takes your blood sample?
There are actually several types of blood tests that your doctor may perform, depending on your symptoms and what they are looking for. These include tests to look at your blood chemistry, the enzymes present in your blood, tests of how well your blood is able to form a clot, tests to assess risk for heart disease, or a complete blood count. A complete blood count can detect the presence of many diseases and immune system disorders by measuring the numbers of red and white blood cells, platelets, blood cell fragments that promote clotting. Hemoglobin, the protein that carries oxygen, hematocrit, the amount of space taken up by red blood cells. And mean corpuscular volume, a measure of the size of red blood cells. Blood chemistry tests provide information about the health of your muscles, bones, and organs. This test reports blood glucose, calcium, and electrolyte levels. It will also test the function of your kidneys. This is often a test that requires you to not eat any food for some length of time before the test so that the doctor can get an accurate measure of your blood chemistry that is not influenced too heavily by what you have eaten recently. Blood tests to assess heart disease focus on measuring your cholesterol levels. This includes low-density lipoproteins, LDLs, often called bad cholesterol, high-density lipoproteins. HDLs, often called good cholesterol, and triglycerides, a type of fat. This test also typically requires you to not eat for about half a day prior to having your blood taken, as your cholesterol levels can be easily influenced by what you have recently had to eat. While blood tests typically cannot diagnose diseases themselves, they can provide a strong indication of what disease you may have and direct your physician to provide other tests that can confirm a diagnosis.
Why did Jacobus Henricus van 't Hoff win the Nobel Prize for Chemistry?
For discovery of the laws of chemical dynamics and osmotic pressure in solutions. The first Nobel Prize ever awarded went to van 't Hoff for his discoveries surrounding osmotic pressure and chemical equilibrium. If a solution of sugar water was separated from a volume of pure water by a membrane that allowed water, but not sugar, to pass, van 't Hoff discovered that additional water would force its way across the membrane until an equilibrium was established. This results in a greater pressure on the side to which the water is moving. And this pressure is known as osmotic pressure.
What is Celsius?
Common temperature scale in which the melting and boiling points of water are defined to be 0 degrees Celsius and 100 degrees Celsius, respectively.
What metals are naturally present in biological systems?
Sodium, magnesium, vanadium, chromium, manganese, iron, copper, nickel, cobalt, zinc, molybdenum, and tungsten are all naturally present in varying quantities in biological systems.
Why is heating often used in chemical synthesis?
Heat is often used in chemical synthesis to increase the rate of a reaction. In some cases, heating is also used to effect a phase change. To minimize the environmental impact of a chemical synthesis, it is often optimal to seek reactions that proceed readily at ambient temperatures so that energy input in the form of heating is not necessary.